Today, I'm going to talk about AI knowledge bases and how you can orchestrate them with Airflow. So let's just start by looking at the agenda for today. So we're going to have three parts. The first part is going to be just a regular introduction. What is generative AI? I'm pretty sure like most people in the room know about Gen AI, but I just want to make sure like everyone is on the same page. Then the second part is going to be about knowledge bases. What are knowledge bases? What is it? And then how you can use Airflow to orchestrate all that. And then finally, the last part would be like just best practices and tips, and then conclusion and a small Q&A session. So yeah, my name is Theo Lebrun. As you can see, I really like pizza. I also live in New York right now, so just wanted to capture that with a New York style pizza. But yeah, I'm a senior data engineer and technical manager at EPON Technologies. Just few words about my company. We are a consulting firm. We have like 4 practices: a data practice, that's the one I'm part of. Then we have a software, a cloud/DevOps, and then a product practice. You also have like links to like all my information. So if you want to connect on LinkedIn, I also have my GitHub profile, my Twitter accounts, and then also a personal website where I have like all the talks that I've done. And also like I also do like blogs. So if you're curious, you can just click on the link or just type in the URL there. So yeah, what is generative AI? So like I say, I'm pretty sure most people are aware of Gen AI. I'm sure you use ChatGPT, Claude, Gemini, Meta, etc. But just wanted to talk about it a little bit, just to make sure that everyone is on the same page. So Gen AI, the whole point of Gen AI is really to like generate a human-like text based on a query or a prompt. So you can ask a question, it will generate an answer to that question. And something very cool is you can enhance it with a context, and that's called RAG. And the next slide is going to be about RAG, just explaining what it is. But that's pretty cool because then you can really provide whatever information you want on top of your question. Gen AI is tailored. You can pick a model. You have different providers. So I listed a bit of the providers on the right side, but there's like a lot of them available. You also have like types of models. So you can have, small models, medium models, large models. Again, depending on the use case, you can kind of pick which model you want. And then finally, like a parameter that I like to use, it's called temperature, which is basically like I would say randomness or the creativity of the answer from your Gen AI application. So for example, if you pick a temperature of 0, it will be like very straightforward. And if you have a higher temperature, let's say 1, it will have more randomness and more like creativity. So very useful if you want like, let's say generate an email or, generate something that needs to have more text, like a blog post or like a book, etc. In terms of use cases for Gen AI, there's a lot of use cases. I would say the main one right now is customer support. Very common, you're like on a website, you ask for support, you will think you're speaking to a real person, but it's actually a bot, like a Gen AI chatbot in the background. You can also use it for like content creation. The thing right now is pretty big is like videos. I'm sure you've seen videos that are like generated with AI. And then virtual assistants like copilots and other type of assistant that can like assist you when you're like, doing code or like exploring a database or like doing other things. There's obviously like a lot of other use cases, but again, that was the few use cases I wanted to highlight in this presentation. So let's talk about RAG. What is RAG exactly? So we start from a query, a question. From that, you're going to search relevant information based on that question, and you're going to use knowledge bases for that. So that way, if you ask a question, I don't know, for example, about a movie, you're going to be able to get all that information from your knowledge bases about the movie. Then you're going to come back with that information. You're going to create what's called a context. And then you're going to add the context to your query and then send all that to your LLM. And then it will generate an answer and then come back with the answer. So RAG is very powerful. By the way, RAG, I didn't mention it, but it means retrieval augmented generation. It's very powerful because let's say you have like a lot of data and you want people to be able to ask questions about that data. So even if you have like a lot of data, it doesn't matter because at the end, you're only going to get the data that relates to the question that you're asking. So very important. And right now, like a lot of companies are using RAG to do like great things. Like for example, they have large databases or like a lot of internal documents, etc. And that way, like their user can ask questions about those documents. And I would say the cool thing is it's not just about like searching, in the document. It's really about asking a question and then get an answer from it. So very powerful. So I want to talk quickly about a chatbot that we did at my company. We called it Epon Assistant. Very simple. It's a GenAI Slack chatbot. It has access to like different knowledge bases. So if you remember, my company, we're like a consulting firm. So we have like a lot of resume. All our like consultants have a resume. We also have case studies. Every time we do a project, we create a case study. And then we have like all sort of internal documents. So for example, our employee handbook, healthcare benefits, etc., etc. So you can kind of see like what I mean by like knowledge bases. You're going to have one about resume, one about case studies, and then one about like any internal documents. And here it's a quick example of how the chatbot works. So for example, if I ask a simple question, I'm like, hey, who has Snowflake experience? It's going to be able to know that based on the context, based on the documents, and then tell me, quick summary of all those resumes that have Snowflake experience. And again, they're very powerful, very useful, and that process, to build is not that complicated. Of course, there's a lot of things to be done, but at the end, the results are pretty great. So knowledge bases, like I mentioned, in our case, we have your resume, documents, case studies, all that kind of thing. So you have like all those different sources. You can have file-based. You can also have a database, graph database, like a warehouse or like a non-SQL database. You can also have third parties, like, I don't know, APIs or like all sort of formats. So it's very challenging to have all those different formats and, put them into your knowledge base. You also like need to define what are the data requirements. So for example, like how are you going to collect the data? You're going to have to clean it. You're going to have to standardize it because you really want the data to be the same for like each type of format. So that way your GenAI application will have very easy time to like understand and look through it. You also want to define, what are the update frequency? For example, if we take the example with the resume, if we have a new consultant, we have a new resume, right? If we have to wait, I don't know, like a week or two to have that resume available in the knowledge base, it's not worth it. So again, very important to define how often you want to update those knowledge bases. And then if you like data, you can put like some metadata, some tagging. So that way you will be able to filter the documents based on the tags and all sort of things. So very useful. For example, like an example I like to use for tagging is, let's say I have documents that I only own. I don't want other people to ask questions about my documents. I'm going to be able to do that with tags. So that way, my GenAI application will only access the documents that I own. And then finally, we talked about all the different sources of documents. You're going to have to integrate that. So like I say, you have a lot of different type of documents, docs, PDF, text files, etc. It's always challenging. You probably know like how it is to work with like PDF or docs. Sometimes you take a long time like parsing and all those things. And then also like something I want to highlight is chunking strategies. So let's say you have a big document, like let's say the document is like 100 pages. You want to chunk it into like smaller chunks. Because think about it, when you ask a question to your knowledge base, most of the time you only care about like a small portion of the document. You don't care about the whole document. So in order to make things faster for your GenAI application, you want to chunk everything. So now you're probably thinking, all right, I see where this is going. I need a tool to orchestrate all that, to like collect, clean some data, to update it at a certain frequency, tag it, etc. And that's where Airflow like will shine, right? So this is like an example of the architecture. So I'm just going to go left to right, but on the left side, we have like all our source of data. So for example, a graph database, Snowflake, cloud storage, like any cloud storage will work. But in our case, for our Epon Assistant, it's S3. And then we have Google Drive. So all the sources are being orchestrated by Airflow. And then Airflow simply generates the embeddings. I didn't really talk about that part, but when you create a knowledge base, you basically create embeddings. And then after creating them, you store them into a vector store database. In our case, we're using AWS OpenSearch serverless. And by the way, to do like all the code, like all the transformation, we use a LangChain Python, which is like an LLM framework. But yeah, like really, I would say the heart of the architecture is in Airflow because it's in charge of like orchestrating all that and making sure that, everything gets updated, everything gets cleaned, standardized and all that, and then stored into a vector store database. Then if you want to know more detail about the application, this is the final architecture. So at the end, the brain of the app, which is like how we're going to, interact using our LLMs, we're using Bedrock. So we have access to like a lot of different models, so like Claude or Llama, etc. And then we expose everything through an API gateway. So that way, if you have a web application or like a Slack bot, you can easily interact with your GenAI application. So again, this is the architecture. Very simple. There's like a lot of things missing, but again, we don't have a lot of time, so we didn't want to spend too much talking about the architecture. So now I want to talk about DAGs. Like, what are you going to have in your DAG? So in our case, the first thing we do, and sorry if it's like a bit hard to read, we update the source to S3 because, through the DAG, we're going to interact with that source. So we just want it to be available in a centralized data store. So in our case, Amazon S3. So let's say we take like a resume, it being uploaded to S3, then we clean it, we chunk it, we save the chunks also to S3. That's just for us to be able to like easily, know and look at the chunks. In parallel, we also like generate and save the embeddings into a vector store database. And then finally, we just do some S3 cleanup because, remember at the start of the DAG, we upload the file to S3, we just clean that up, and then we notify on Slack to make sure that everyone is aware that the knowledge base was updated. This is a very simple DAG. Again, in real life, you're probably going to have something a bit more complicated than that. But again, I just wanted to stay simple for the presentation. But yeah, at the end, depending on the documents and what's in the documents, you might have to have a lot of extra steps or tasks. So a couple of tips and tricks. In terms of like the DAG processing, very important. Since you're going to manipulate like a lot of data and a lot of documents and all those things, you really want to delegate the data processing part of your process, of your DAG, so that way it doesn't run directly on Airflow. This is just like, standard practice, because you don't want to do something that will cost you a lot of CPU and memory directly on your Airflow instance, because let's say it crashes, then you lose everything. So I recommend like using, if you're on AWS, you can use ECS, very useful for that. Or if you're on Kubernetes, you can have like pod operators. You have other ways to do it. But again, the whole point is to delegate the data processing. Also, DAG should be idempotent. What it means is that if you give the same input to the same DAG, you're going to have the same output, no matter how many times you do it. And the whole point of that is just to be able to like retry and avoid a situation that if you want to do the same thing, you get a different result. So very important. And then you also want to optimize your task. What it means is that each task should do like something small. That way it's like easy to identify, and really every task is like independent from each other. And same thing, if you want to replay it, if it fails, it's easily replayable. So that's why you want to break down your DAG into like a lot of different tasks. Then in terms of like knowledge bases, couple things. In our case, if you remember, we have resume, we also have case studies, and then finally internal documents. So we basically have multiple indexes. Why we did that is just to reduce LLM hallucination. So that way, if you ask a question about a resume, you're only going to get your resume back, right? You're not going to get case studies or like internal documents. So it's a bit, I would say, a bit more complicated to manage because you're going to have multiple indexes, and, for each indexes, you're going to have a specific prompt. But at the end, you're going to be able to like really isolate and reduce LLM hallucination. Another thing also I want to talk about is really the importance of preparing and cleaning and standardizing your data. Think about it that way. If the data is not good, you're not going to have good results. So it's very important to have the best data you can available to your like GenAI application and in your knowledge base. So that way you're going to have the best results. And then finally, just add as much metadata to your documents as you can. It's probably going to be useful later. Usually when you start your GenAI application, you don't know much, you just want to do something simple, but then down the road, you're going to use a lot of that metadata to have better result and all those things. So yeah, to resume, in terms of like the DAGs, really like don't do any processing, especially if it's like a lot of data. It requires like a lot of CPU directly on your Airflow instance. Delegate that. And then for your knowledge bases, make sure to like have indexes so that way you can get better results. So yeah, just wanted to say thank you for your time. I would love to chat more about using Airflow and building Gen AI application. Here's a QR code if you want to scan it. That'll just redirect to my LinkedIn profile. But yeah, thank you.